Hello, it's Mrs. Green, and today's lesson is triangles and their area. So we're going to start with some of the definitions that we'll need for working with triangles. And so the first thing I want you to do is write down your prior knowledge of triangles. Prior knowledge. And some of that might include what I've got shown here in the graphic, which are different types of triangles. There are two ways to classify triangles: by their angles and by their sides. So we've got a graphic up here that does both of that for you. I'm going to have you put this in your key information in a minute, but if you already know some of this information, that might be what you put in your prior knowledge. How many sides are in a triangle? There are going to be some things that you already know about triangles. So key information. Okay, so your key information is going to include first some definitions, and so I want you to draw a triangle. I've got 4 here, so draw at least one, and you're going to label these pieces of a triangle. One is the vertex, and the vertex is any point. So if I look at the pink triangle and I make point A the vertex, that's the point where the 2 rays come together. It's the corner. All right, so vertex would be one of the corners, so just make sure that one of your corners is labeled, and we do use the capital letters like we do with angles. The other part of a triangle is the base, and the base can be any of the sides. It doesn't have to be the bottom side. So in my pink triangle A, I'm going to change it up here just so that you can understand that the base can be any side. So I'm going to name my triangle ABC, and the base I'm going to choose is the base that goes from B to A. So notice I did not choose the bottom, the AC base. And like the green triangle doesn't even have a base that's facing the bottom, so you would have to choose a different base. And that's fine. Any of the sides can be the base. It doesn't have to be the bottom. It doesn't have to be sitting on its base. Sometimes people think it does. And then the third piece, so each of them has a base. So I'm going to identify a base. Actually, let me just do red for each of my bases. So my bases, I'm going to identify them as red. So A, B, C, D, E, F, L, M, G, and X, Y, Z. And they each have a base. And then the last part of each of these triangles I want you to identify is the height, which is also called the altitude. That's how high something is. It's altitude. It's usually something we a lot of times refer to when you're up in the mountains, how high the mountain is. And the altitude is going to be a line, not necessarily another side, that's perpendicular to the base. So it has to be perpendicular, and perpendicular means at a 90-degree angle. There's a picture of perpendicular. It has to be perpendicular to the base. And it has to touch the vertex that's opposite the base. So the vertex that's opposite the base of my pink triangle is C. C is the vertex that's opposite the base. The base is in red. So I'm going to draw in, let's see, how about purple? I'm going to draw in purple what the altitude would, or the height or the altitude. So it has to be perpendicular. So it has to be coming off 90 degrees. And it has to touch the vertex going to the other side. That's my height. And I'm going to make a little 90-degree angle indicator, indicating that's 90 degrees. It's supposed to be purple. Let's do it in green. Oh, green's not going to show up on green. Okay, black. Black it is. So in my green triangle, I need to go from my base, which goes from D to E, down to F. And in my yellow triangle, I have to go from L, which is my vertex that's opposite my base. My base is going from M to G. But guess what? It doesn't reach. So if I want to go perpendicular, I have to draw down from L. Okay, I'm not right on L. And then I have to be perpendicular to my base. So I've got to extend my base. Extend my base out so that I've got room to make a perpendicular line coming down from my vertex. And then XYZ would be from X down to Z, which looks like it already has a 90-degree angle. So those are your 4 bases, vertexes, and altitudes or heights. You need the base to be able to calculate area. Okay, next thing I want you to do is draw a table, like the picture here, that depicts the 3 types of triangles that are classified by angle, and the 3 types of triangles that are classified by their sides. So here's a nice picture in green of an equilateral triangle, which means all 3 sides are equal. This little mark means that those are congruent. Isosceles means 2 sides are congruent. Scalene means none of them are equal, or by equal it means none of them are the same length. Then we've got angles. Acute means one of the angles is less than 90. Right means one of them is 90. And obtuse, one of them is greater than 90. I guess acute, they would all 3 be less than 90. You can't have, you could have an acute triangle where they don't all 3 have to be less than 90. You could have a 90-degree angle and have 2 acutes. Yeah, I'm not sure. I'm going to put at least one. At least one angle is less than 90. Okay, so you're drawing that. And then a couple of things to recall. So one of them is that the sum of the angles in a triangle is 180 degrees. We worked with that a little bit on one of our worksheets last week when we were working with circles, because a circle is I don't know that we worked with that. Seems like when we were measuring with our protractor, a few of you knew that already, so we talked a little bit about that. But this is a reminder. This is not something new, but it might be something you've forgotten. So if you add up all the angles in a triangle, they have to total up to 180 degrees. So write that down in your notes, and then we'll go on to the area formula for triangles. So the formula for the area of a triangle comes from the area of a rectangle. And if you remember, an area of a rectangle is something we've done in the past. You've learned this before, and we did a rectangle activity last Monday, I think it was. You have length and width, but we're going to rename those, and we're going to call them base and height. We're going to start talking about base and height when we talk about our 2 dimensions. And if you draw a triangle, you can see from, if I shade the area that's taken up by the triangle, it's not the whole rectangle. The whole rectangle area would be base times height. It's half of it. So the area of a triangle is 1/2 base times height. Another way to write that is base times height over 2. So that's area of a triangle. Area of a triangle. This is area of a rectangle. And it's nice because we all know area of a rectangle. That one we all have memorized. You have to translate it to base times height now. We're talking about base and height, not width and length. It's the same thing. But we have to take the elementary school definition and translate it into the more middle school and high school definition, which is base times height for a rectangle. So a triangle is half of that, as you can see from this picture. So it's nothing new to memorize. You just have to remember it's only half. The triangle doesn't take up the whole rectangle. Another way to picture that, oops, that's not what I want. Another way to picture that is even if your rectangle isn't taking up half of your, oh, you know what? I'm not gonna talk about that. I'll talk about that in class. Okay. All right, and last piece of key information is, if you recall what perimeter means, that's the distance around a figure, so around a triangle, it would be, if you walked all the way around, it would be the distance. So you would have to measure, let's say this is 5 feet, and this is 7 feet, and this is 9 feet. You would do a 5 plus 7 plus 9. It's like you're building a fence around it, you're walking around it. Versus area, which area is the part that's going to cover the whole triangle up. So perimeter is around, and there's no formula, you're adding up all the sides. Okay, let's do some sample problems. Okay, example 1. They give us a picture, and this is actually supposed to be a sail, like a sailboat. So it's got a nice pretty design on it. And they give us some dimensions, 171 inches on that side, 159 inches. And on this is also 159 inches. And we're going to choose as our base, we're going to choose the bottom. Usually I choose the bottom if there is a bottom. But again, you didn't have to do that. You could have chosen the 179. I mean the 171. And notice none of the corners are right angles. So I don't have a height. I can't use the other sides as my height. My height has to be coming from the vertex that's opposite my base. So my base I traced in green. The vertex opposite, I just put a black dot on it. And I'm going to draw the height, which comes down from the vertex and is perpendicular, which means it's at a 90-degree angle, to the base. And they have given me that is 144 inches. So sometimes there's confusion on which of these dimensions to use. So the first thing I'm going to do is calculate perimeter. So they've asked me to calculate the perimeter of the sail and the area. So the perimeter, remember, I'm going to go around the sail, which you would never do, but we're practicing. So if I go around, that means I am going 171 inches. I don't want blue again. Purple. I'm going to go 171 inches, and then 159 inches, and then another 159 inches. So that's a pretty easy calculation. I'm just adding the sides. Now notice I did not do anything with 144. That doesn't help me with perimeter. That has nothing to do with the edge. That's the height measured from the vertex down to the base. So I'm going to need that for area, but it doesn't help me with the edges, which is what I need to calculate perimeter. So to calculate perimeter, I'm going to add these three numbers up, and I get 489. Okay, area. I'm going to write my area formula. So area of a triangle is, let me just make my shape. Area of a triangle is 1/2 base times height. So A equals 1/2 base, which I said was my green, 159. And height, it has to be perpendicular. So I'm going to use the 144. And I'm going to do my multiplication. So that's 1/2. 159 times 144 times 1/2. Okay, after I did that multiplication, I got 11,448 inches squared. And it's inches squared because I'm multiplying 159 inches times 144 inches, and inches times inches is inches squared. Up here in my perimeter, I forgot to label it the first time, and it's just inches because you're adding, you're not multiplying. So you didn't change the units. And I'm pretty bad about labeling, so when I forget to label, please, and you notice, go ahead and label yours, and then tell me in class, and we can talk about how lame I am with my labeling. Okay, so that's example 1. Okay, example 2 says find the area of the triangle. So I'm going to draw a triangle, and this one's going to be acute enough so that my my altitude or my height is going to be one of those funny heights where you have to extend your base. So we want to find the area, and so remember my area formula. Area of a triangle equals 1/2 base times height. So when I plug all those in, it's not a difficult calculation. The difficulty here is figuring out which sides I'm going to use as my base and my height. So nothing's 90 degrees. I would have marked it. This one corner kind of looks 90 degrees, but it's not marked, so we can't assume. And they've told me that the smallest side is 7. This side right here is 20 meters. And then they didn't tell me the other third side, but they gave me the height. And the height, if I extend so let's say my base is the 7. If I extend it out, then remember, I'm going to go opposite my base to the vertex, which is up here. So the red line is my base, the red point is my vertex, and now I can draw a line that comes straight down and is perpendicular to my base that I've extended. I've had to extend my base. Now that red extension where it's kind of dashed, that's not part of my base. That's not part of the number that I'm going to use to calculate the area. I've just had to extend it in order to make this physically work, because my altitude, my height coming down, wouldn't touch my base. It's outside. So we have to kind of manipulate the triangle by extending the base. And they've given me in the diagram that that's 16 meters coming down. So that 16 is not this side. I don't need that side. That side's not perpendicular to the 7 base, so it doesn't help me. I had to make a new line. All right, so now I can fill in my formula. My base is 7. My height is perpendicular to my base, so it has to be the 16. The 20 is not perpendicular. It's not going straight up and down at a 90-degree angle. So now when I do that multiplication, that's really, I'm going to divide 16 by 2. That's going to be easier math. So 8 times 7 is 54. 56, oops. This is green, you don't know your math facts. Meters squared. All right, 3 practice problems. You need to find the area and the perimeter for each, so you actually have 6 problems. And there the diagrams are. You have inches, centimeters, and yards. Please remember to label your units. I think those are all the practice problems I was going to do. Yeah, 1 through 3. Okay, see you tomorrow.